This is Pre-Calculus section 12.2 notes. We're going to start by taking a look at our limit laws sheet that you were given in class. And this is just a listing of all of the different limit laws that we're going to be using in the next two sections. So we're going to say, suppose that c is a constant and that the following exist. The limit as x approaches a of f of x and the limit as x approaches a of g of x. Then the limit of a sum is the sum of the limits. The limit of a difference is the difference of the limits. The limit of a constant multiple times a function is the constant times the limit of the function. The limit of a product is the product of the limits. The limit of a quotient is the quotient of the limits. The limit of a power is the power of the limit. And finally, the limit of a root is the root of the limit. Then on the back side, we've got a couple of special limit laws here. Our first one, the limit as x approaches a of c equals c. So with a number example here, the limit as x approaches 2 of 7 is still going to be 7. In example 2, the limit as x approaches a of x equals a. So the limit as x approaches 5 of x will be 5 because x is 5. In number 3, the limit as x approaches a of x to the nth power is equal to a to the nth power, where n is a positive integer. So for a numeric example, the limit as x approaches 4 of x cubed would be equal to 4 cubed, which would be equal to 64. And then finally, the limit as x approaches a of the nth root of x is equal to the nth root of a, where n is a positive integer and a is a number greater than 0, just keeping it real there. So the limit as x approaches 8 of the cube root of x would be equal to the cube root of 8, which would be equal to 2. Okay, so now transitioning to our note packet, let's take a look at a couple of examples here. In example 1, it says to use the limit laws and the graphs of f and g to evaluate the following. Letter A, the limit as x approaches 2 of 3 times f of x plus g of x. So the first thing that we're going to do is we're going to use our limit laws, and we're going to say that the limit of the sum is the sum of the limits. So I'm going to rewrite this as the two limits being added together. So this will be the limit as x approaches 2 of 3 times f of x plus the limit as x approaches 2 of g of x. And then I can say that the limit of a constant multiple times a function is equal to the constant multiple times the limit of the function, basically just bringing that 3 in front of the limit. So then this is going to be 3 times the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. And now I can use my graph, okay? So I'm looking at the limit as x approaches 2. So hang on here, this is a little bit hard to read. So here is my y-axis right there, okay? So the limit as x approaches 2, so when we're looking at 2, this is going to be the limit as x is approaching 2. So when we're looking at our graph here, there are two functions. There's the f function, which is on the top, and then there's the g function, which is on the bottom. So first we're doing 3 times, change color here, 3 times the limit as x approaches 2 of f of x. So here f of x is on the top, and 2 would be right here. So the limit as x is approaching 2, looks like this is 2, appears to be right here, right? And here's my x-axis. So if we look at when x is 2, the limit as we approach 2 from the left and the limit as we approach 2 from the right agree, and the limit appears to be 1, plus the limit as x approaches 2 of g of x. So now let's take a look at that. Well, as g of x approaches 2 from the left, it looks like we are approaching -3, and as g of x approaches 2 from the right, it looks like we're approaching -2. So the left-hand limit and the right-hand limit don't agree when x is 1 for the function g, so we would say that the limit there does not exist. So 3 times 1 is 3, but 3 plus something that does not exist, we have to say that based on the graphs that we are given, this limit does not exist. In example B, we have the limit as x approaches 0 of f of x times g of x. Well, we know that the limit of a product is equal to the product of the limits. So that's the first law that we're going to use, and we're going to rewrite this as the limit as x approaches 0 of f of x times the limit as x approaches 0 of g of x. And now we can look at our graph. And we're going to look at f of x first. So right here, well, that's hard to see, but right there is our x equals 0. So the limit as f of x approaches 0 right here from the left and right here from the right appears to be the same, right? So the left-hand limit is 0 and the right-hand limit is 0. So the limit as x approaches 0 of f of x is going to be 0 times, now let's take a look at the limit as x approaches 0 of g of x. Well, when we're looking at the g function, as we approach 0 here and as we approach 0 here, the left-hand limit and the right-hand limit appear to agree, and that looks to be about -2.5. So I'm going to say this is times -2.5. But as we know, 0 times anything is going to be 0. So that's going to be our answer for example B. Now we move on to example 2. In this one, we're not using a graph. We're just using our limit laws to evaluate the limit, and we're going to justify every step that we make using the appropriate limit laws. So we've got the limit as x approaches 3 of the function 2x squared minus 5x plus 1. So the first thing that I'm going to do is I am going to break this apart. I'm going to say that the limit of the sum of a limit is equal to the limit of the sums, or excuse me, the limit of a sum is equal to the sum of the limits. Said that backwards. So basically, I'm just going to separate this 2x plus 5 from this positive 1. That's going to be my first step. So I'm going to say I'm going to change color. That's a little light. The limit as x approaches 3 of 2x squared minus 5x plus the limit as x approaches 3 of 1. And my justification is this is the limit of a sum. Okay, next I'm going to focus on breaking apart the 2x squared minus 5x. That is the limit of a difference, and we know that the limit of a difference is equal to the difference of the limits. So I'm going to break that apart into two limits. So that's going to look like the limit as x approaches 3 of 2x squared minus the limit as x approaches 3 of 5x plus the limit as x approaches 3 of 1. And this is limit of a difference. Then I am going to use my product rule, my power rule. The limit of a power is equal to the power of the limit. Okay. And I'm also going to bring that 2 out in front. So I'm going to bring that the constant multiple and the power. I'm going to do those at the same time. So this is going to look like 2 times the limit of x as x approaches 3, and then that quantity is going to be squared, okay, minus 5 times the limit of x as x approaches 3 plus the limit 1 as x approaches 3. And here I use the limit of a constant multiple. Okay. And now finally that I have simplified this completely using the limit laws, now I can go ahead and I can plug in my value of 3. So this is going to look like 2 times 3 squared minus 5 times 3 plus 1, right? Because the limit as x approaches 3 of x would be 3, and the limit as x approaches 3 of x would be 3, so the 3 is going to go in both of those locations. 3 squared is 9, so this becomes 2 times 9 minus 5 times 3 plus 1, which gives me 18 minus 15 plus 1. Finally, 18 minus 15 is 3. 3 plus 1 is 4. So the answer here is that the limit as x approaches 3 of 2x squared minus 5x plus 1 equals 4. In the next example, we're going to use direct substitution to find the limit. We're just going to substitute the a value into the function. And when this works, it's awesome because it's quick and it's easy. So we're going to do the limit as x approaches -1 of our function x squared plus 3 divided by x plus 8. So we're simply going to plug the -1 in for the x, and we're going to evaluate the function at that value. -1 squared is +1, and then -1 plus 8 is 7, and then finally 1 plus 3 is 4, so I end up with 4/7, which is approximately equal to 0.57 if you were to divide that on a calculator. And how could you check if you had the correct answer? Well, one thing that you could do is you could graph your x squared plus 3 over x plus 8 and use the trace key on your calculator to look at both sides of -1 and make sure that the value is approaching, as x is approaching -1, the value of the function is approaching 0.57. Okay. So again, when you trace the graph as the value of x approaches -1, the value of y approaches 0.57. There is one thing to note here. Direct substitution will not work when the substitution creates a 0 in the denominator. Okay, so this is something that you have to check before you substitute. Okay, so direct substitution is awesome when it works, but it's only one thing in our bag of tricks. So in the next examples, we're going to look at a few other options. Example 4, we're going to use first factoring as a method and then simplifying. So we're going to look at we're going to look at 2 different problems, and we're going to look at 2 different ways to tackle how to evaluate the limit.